Now, today we are going to discuss about a very interesting form of Jorsic equation that is known as canonical Jorsic equation. Let us look at what do you mean by canonical Jorsic equation. Treating the parameter t to be arbitrary, we have derived the Jorsic equation on the surface, which we have seen in this chapter as a theorem 1. Therefore, in place of t, we may choose the arc length small s of the curve measured from a fixed point on it as parameter and obtain the Jorsic equation in a much simpler form. This simpler form is called canonical form. So let us look the Jorsic canonical Jorsic equation. Now, this theorem is related with this canonical Jorsic equation. What is the statement of the theorem is if the arc length is small s is the parameter of the curve, then the Jorsic equation are capital U is equal to d by dt of del t by del u dash minus del t by del u is equal to 0, and capital V is equal to d by dt of del t by del v dash minus del t by del v is equal to 0. Let us suppose this is equation number 1. The equation 1 are called, the combined this equation 1 are called canonical Jorsic equation. Now, let us look the proof of this canonical Jorsic equation. Since the Jorsic equation are true for any arbitrary parameter t, it is equally true for the parameter s. Also, the Jorsic equation becomes capital U is equal to d by ds of del t by del u dash minus del t by del u. And this is after this differentiation, you can write this the same as 1 by 2t d capital T by ds and del t by del u dash. This is equation number 2. So both are equivalent. This whole part is equal to this whole part. And v is equal to d by ds del t by del v dash minus del t by over del v is equal to 1 by 2t dt by ds del t by del v dash. This is equation number 3, where t is equal to half e u dash square plus twice f u dash v dash plus g v dash square. Since u dash is equal to du by ds is equal to L and v dash is equal to dv by ds is equal to m, therefore both are u dash and v dash are the directional coefficient at a point on the curve, and EL square plus twice f Lm plus gm square is 1. Now, a capital T is half of EL square plus twice FLF plus GM square, which is equal to half, so that dt by ds is equal to 0. This is equation number 4. Using equation 4 in the right hand side of 2 and 3, we obtain the canonical Jorsic equation 1. One should note that capital T is equal to half only along the curve, and it is not equal to half identically for all values of u, v, u dash and v dash. The partial derivative dt by du dash and dt by dv dash are calculated from capital T before we substitute the values of u dash and v dash in capital T. If the curves on a surface are not parametric curves, then the sufficient condition for a curve to be Jorsic is either capital U is equal to 0 or capital V is equal to 0. For a parametric curve U is equal to constant to be a Jorsic, a sufficient condition is capital U is equal to 0 and small v is equal to constant to be a Jorsic. The sufficient condition is capital V is equal to 0. When small s is used as a parameter, then capital U u dash plus capital V v dash is equal to dt by ds. Since dt by ds is 0 by equation 4 of the previous theorem, so we have u u dash plus v v dash is equal to 0. If the curves are not parametric curves, then it means u dash is not 0 and v dash is also not 0. This implies from 1 that u and v are not independent. Hence, u is a scalar multiple of v and vice versa. So, either capital U is 0 or capital V is equal to 0 is a sufficient condition for a curve to be Jorsic. So this is the first part of theorem. Second, for a curve to be Jorsic on a surface, it should satisfy the following canonical equation of previous theorem 1. U is equal to d by ds of del t over del u dash minus del t over del u is 0. Let us suppose this is equation number 2, and capital V is equal to d by ds of del t over del v dash minus del t over del v is 0, which is equation number 3. If you take the parameter parametric curve is equal to constant, so that u dash is equal to 0 and v dash is not 0. Using this in 1 implies that capital V is equal to 0 and conversely. Hence the equation 3 is automatically satisfied for all s. So the condition for u is equal to constant to be a Jorsic is capital U is equal to 0. In a similar manner, capital V is equal to 0 is a sufficient condition for the parametric curve V is equal to constant to be a Jorsic. Thank you very much. Thank you. Stay safe.